Hello viewer, welcome to Samuel Academy. In this video, I want to discuss about gas laws, both in chemistry and physics. Before I do that, I want to explain more about variation. We have direct variation and inverse variation. We have two variables, x and y. They vary. So in the first instance, that is direct variation, when y increases, x increases. When y decreases, x decreases. That is direct variation. And this is how we represent the information that y is directly proportional to x. Okay? That is, as y increases, x increases. As y decreases, x decreases. So we write it this way. It implies that y is equal to k times x. So from here, you write this. So this k is a constant. All right. Now, the next variation is inverse variation, which means that y is inversely proportional to x, implying that when y increases, x decreases. When y decreases, x increases. So this is a case of inverse variation. All right? So this is how we write it mathematically. We multiply this part with k, a constant, and instead of this proportionality symbol, we put equal to. So y is equal to k over x in the case of inverse variation. So k in these two cases is the constant of proportionality. K is a constant. So I want us to apply this knowledge to the gas laws, how the variables vary. The first law we shall look at is Boyle's law. Boyle's law says that the volume of a gas is inversely proportional to its pressure when temperature is constant. So I've shown this graphically, that when the volume of a gas increases, the pressure decreases. When the pressure decreases, volume increases. All right? That is Boyle's law. Temperature does not change, is constant. And we can show this in graphical form. This is the y-axis, this is the x-axis. On the y-axis, we have pressure in pascals. And the y-axis, the x-axis, we have volume in cubic meters. So we can see from this graph, when pressure is high, volume is low. As pressure decreases, volume is increasing. So this is the relationship. And this is how we relate it mathematically. That volume of a gas is inversely proportional to its pressure at constant temperature. So this is the proportionality symbol. So we write this mathematically, replace this with the equal sign. You say that volume is equal to a constant times 1 over P, or volume is equal to K over P, where K is the constant. All right? Now, from here, you can make K the subject of the equation. Then we have, you multiply both sides by P, you get P times V is PV is equal to K. So this is Boyle's law. PV is equal to a constant. Next is Charles' law, which says that the volume of a gas is directly proportional to its absolute temperature at constant pressure. So in this case, we can see that as volume increases, we see temperature also increasing. So this is direct variation. When one variable increases, the other variable increases. When one variable decreases, the other variable also decreases. So this is how we write it. Volume is directly proportional to its temperature, the absolute temperature, not Celsius but absolute in kelvins, implying that the volume is equal to a constant times temperature, pressure remaining constant. We can show this graphically. This is the y-axis, this is the x-axis. On the y-axis, we have volume in cubic meters, and on the x-axis, we have temperature in kelvins. This is the graph. As volume increases, temperature also increases, and so on. As volume decreases, temperature decreases. So V is directly proportional to T, the temperature, the absolute temperature, implying that V is equal to K times T, where K is a constant. So if you make K the subject of the equation, you find that you divide both sides by T, so you get V over T is equal to K, and this is Charles' law. Now we have what we call the pressure law or Gay-Lussac's law. Right? So this law says that the pressure of a gas is directly proportional to its absolute temperature when volume is constant. So the volume is constant, and as pressure increases, temperature, the absolute temperature also increases. This is another case of direct variation, which you write like this. Pressure is directly proportional to temperature at constant volume, implying that P is equal to K times T, where K is a constant. If we make K the subject of the equation, then P, we divide both sides by T, we get P over T is equal to K. That is constant. So this is Gay-Lussac's law or the pressure law. From the graph, we can see that as pressure increases, temperature also increases. That is the pressure law. And finally, we have the combined gas law. We combine the three laws into one, whereas P times V over T is a constant. Pressure times volume over absolute temperature is a constant. So if this is the first pressure, first volume, and first temperature, is equal to the second pressure times the second volume over the second temperature. So this is the combined gas law. P1 times V1 over T1 is equal to P2 times V2 over T2. So I hope this video has been useful and you can apply it when solving problems that are under gas laws in chemistry or physics. So subscribe for more videos in chemistry, physics, geography, weather, and surveying. Thank you so much.